fundamental theorem of arithmetic says every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Means, first of all, you need to understand what do you mean by composite number. See, we have already done this, that composite number are the numbers which are having more than two factors. For example, the first composite number is your 4, 6, 8, even 9, etc. So they are having more than two factors. You can see here 4 is having factors 4, 1 is a factor, 2 is a factor, 4 is also the factor of 4. Factor means which divides 4, which divides completely. So 4 is completely divisible by 1, 4 is completely divisible by 2, 4 is completely divisible by 4 also. So you can see here 4 is having 3 factors here. Similarly 6 is also having 1 is a factor, 2 is a factor, 3 is a factor, and 6 itself is also a factor. Every number is a factor of itself. So again 6 is having 4 factors, that's why it is composite number. Now what do you mean by prime numbers? Prime numbers are the numbers which are having only 2 factors. Prime numbers are the numbers which are having only 2 factors. So first, smallest prime number is 2. 1 is not a prime number because 1 is having only one factor, which is 1. That is why the smallest prime number is 2. And even smallest even prime number is also 2. That is only the one even prime number. So 2, 3, 5 and so on. You can see here 2 is divisible by 1 and 2 itself. Only 2 factors. 3 is divisible by 1 and 3 itself. Only 2 factors. So prime numbers are the numbers which are having only 2 factors, whereas composite number are the number which are having more than 2 factors. So our theorem says that composite number can be expressed as a product of primes. You can see in the example 24. When I have done the prime factorization of 24, we got the answer 2 into 2 into 2 into 3. 2 2s are 4, 2s are 8, 3s are 24. Whenever you will multiply them, you will get the answer. So again 36 also you can see 2 into 2 into 3 into 3. 2 2s are 4, 3s are 12, 3 are 36. So this theorem says that every composite number can be expressed as a product of primes. See, in this slide, we have done the prime factorization with the help of factor tree method. Factor tree method done in the earlier classes. So you can see here that we have factorized this first 11,130, which is, we have made a tree here. 2 into 5,565 is 11,130. So we have now 5,565, again we have factorized this 3 into 1855. 1855 again we have factorized it 5 into 371. 371 again we have factorized as 7 into 53. And after that you are going to write down, the product of all the prime numbers here. So all the prime numbers here. So you can see here prime numbers 2 into 3 into 5 into 7 into 53. So whenever you are going to multiply all the prime numbers here, all the prime factors here, you are getting this question 11,130. You can verify also 2, 3, 6, 5, 30, 30 into 7, 210, 210 into 53 is 11,130. In this slide, we have done the prime factorization, normal prime factorization, which you are already doing. When you are finding the LCM, when you are finding the HCF, you are doing this prime factorization. So, whenever we are going to factorize only single number, don't say it is LCM. It is not LCM. LCM requires pair. So, it is prime factorization. So, 180 we have done the prime factorization. 180 divided by 2, it is 90. 90 divided by 2, 45. 45 divided by 3, 15. 15 divided by 3, 5. 5 divided by 5, 1. So you can check here. Whenever you are multiplying this 2 into 90, you will get this part. Okay. So like this we are doing. After that we are writing 180 is equal to 2 into 2 into 3 into 3 into 5. In this we have written in the form of exponent also. So 2 into 2 we have written as 2 square, 3 into 3, 3 square, and into 5. This we are going to utilize in finding HCF and LCM in this class. You are going to study this relation also in coming exercise. This we have already done in class 5 also. LCM into HCF is equal to product of the two numbers. Whenever you are given two numbers and you are finding the product of that two numbers, finding the LCM of the two numbers and HCF of the two numbers. So this relation is there. Whenever you are multiplying this LCM into HCF, whenever you are multiplying this LCM into HCF, you are verifying that both LCM into HCF product is equal to product of the two numbers. We'll verify in the questions. Whenever product of the two numbers is given to you, HCF is given to you, you are able to find out LCM. How? LCM is equal to product of the two numbers divided by HCF, this one. Whenever you need to find out HCF, you can find out easily by dividing product of the two numbers by LCM. And if in case one number is given to you, you need to find out another number, and LCM and HCF both are given to you. You can find out by using this formula that LCM into HCF divided by one number, that A I have taken here, is equal to another number, which is B. Now we have taken one question. Find LCM and HCF of 40, 36, 126. This prime factorization we have already done. 40 is equal to 2 into 2 into 2 into 5. 2, 2s are 4, 2s are 8, 5s are 40. 2 is repeated 3 times, so I have written 2 to the power 3 into 5. 36 we have done prime factorization, 2 into 2 into 3 into 3. So 2 to the 4, 3 is 12, 3 is 36. I am verifying also side by side. So it is 2 to the power 2 and 3 to the power 2. 2 square into 3 square. After 126 we have done 2 into 3 into 3 into 7. 2, 3 is 6, 3 is 18, 7 are 126. 3 is repeating 2 times here. So 2 into 3 to the power 2 into 7. This one. After that, now you need to remember one thing. Whenever you are going to find out the HCF, we have done the HCF in earlier classes also. So whenever we were finding the HCF, we were taking only the common one. Only the common one. And whenever there were 2, 3 commons, so we were multiplying all the common. We were doing this. And for the LCM, we were taking the common as well as the uncommon. The product of all the common as well as the uncommon. Here also we are going to do the same thing. But we need to remember only one line. For HCF, we are going to take the lowest power of the common. Lowest power. See, now you can see here, it is 2 to the power 3 into 5, 2 to the power 2 into 3 to the power 2. Here, 2 into 3 to the power 2 into 7. Now you can see what is common here. You are going to see only the common in HCF. So common, 5 is not common, it is not there in 3. 3 is also not common because 3 is not there in all. But only 2 you can see here, 2. You can see 2. This 2. 2 is here, 2 is here, and 2 is here. For HCF, you are going to take the smallest power of 2. 2 to the power 1 is the 2 to the power 1. You can see here 2 to the power 3. You can see here 2 to the power 3, 2 to the power 2, and nothing is there means it is 1. 2 to the power 1 is the smallest power. So the HCF is only 2. But for LCM, you are going to take the common, and that should be the highest power of the common. So highest power of the common is the highest power. 2 to the power 3 is the highest power. So I have taken it 2 to the power 3. Now 3 to the power 2 is there in this. 3 to the power 2 is also there. So I'm going to take 3 to the power 2. As well as I've told you that we will take the uncommon also. So we will take 5 or 7 also. So LCM would be 2 to the power 3 into 3 to the power 2 into 5 into 7. Means 2 to the 4 to the 8 into 9 into 5 into 7. Just multiply all of them. You will get the LCM 2520. In this question, we are going to find out HCF and LCM of 3x square y and 6xy square. Now we are splitting this 3x square y as 3 into x into x into y. 6xy square as 2 into 3. We are splitting this number also 2 into 3 into x into y into y. For LCM, you already know that we are going to take common and uncommon both. We are going to take common and uncommon both. So for LCM, we are going to take the common, which is 3, and uncommon also 2. And then x is common here. So I'm taking this x common. And then y is also common. Now 1 x is remaining, so I'm taking the uncommon also, and y here is remaining, so I'm taking this. Ultimately, the answer becomes 3 to the 6, x to the power 2, y to the power 2. So with this answer, you're able to understand that how we are going to take LCM directly. But we're taking the number 6 here, common and uncommon both. In the numerical part, you will not find any difficulty. But for the variable part, we are going to take the variable with the highest power. For example, we are going to take the variable with highest power here. The power of x is 2 and here the power of x is 1. So we are going to take the variable with highest power, which is x square. And similarly, for y also, you are going to take y to the power 2, because we are going to take the variable with the highest power. So LCM is 6x square y square. But for HCF, you are going to take only the common part. So 3 is common. And for the variable part, you are going to take the variable with the lowest power. Now, in this first, x ki power 2 is there, and in this x ki power 1. So I'm going to take x to the power 1. And for y, this part is having y to the power 1. If nothing is there, it means it is 1. And in this, y to the power 2. So I'm going to take again the lowest power of the variable. So the HCF would be 3xy. I hope it is clear to you.